Hi, and welcome to creating RESTful APIs for your mobile apps using Java. We are going to cover not only the code you'll use, but we will also examine the tools used to create a professional Java application. There's no time like the present, so let's get started.
In this video, we'll introduce web services. These are services computers use to communicate information between computers. Then, we'll talk about RESTful web services. These are services created using the RESTful architectural style. We'll also take a look at the advantages of RESTful APIs over other API types. Finally, we're going to look at the basic layers to a RESTful application. The whole point of creating a RESTful API is to get two computers to talk to each other. Now, we might need to notify another computer of an event, make a request to buy airline tickets, or maybe we're just trying to share some deep insight using 140 characters or less. No matter what we're trying to do, we need to move information from one computer to another. Now, we can move this information by directly connecting the two computers, but that breaks down real quick as soon as you try to connect more than a few computers. You need to network the computers in some fashion. To make sure the largest number of computers can talk to each other, you want to use a network that you can guarantee most of the computers can use. That network, of course, is the Internet. Applications communicate with each other using web services over HTTP. HTTP is a protocol that stands for Hypertext Transfer Protocol. Now, you don't need to remember that. You just need to know that HTTP describes the rules for how information is transferred from one computer to another over the web. A web service is a standard way for web applications to pass messages over the Internet. A web service usually performs a single action on the behalf of the machine making the request. The machine making the request is called the client, and the machine hosting the web service is called the server. The web service code is executed on the server. There is no user interface for these services. Only information is communicated in the messages. Client web applications can build on these web services to provide a user interface and to solve a larger problem. A web service allows for single actions like, get me the list of Green Lantern comics from 1980 to 1981. Getting the list of Green Lantern comics would be a simple request. Once the server has fulfilled your request, your conversation is over. A larger workflow, like purchasing an airline ticket, would require a longer conversation. Usually, these longer conversations can be broken down into simpler web services. So purchasing an airline ticket might be broken down into smaller steps like validate credit card, charge credit card, and reserve plane ticket. REST is an architectural style that stands for Representational State Transfer. The term REST and the ideas behind it were coined in 2000 in the doctoral dissertation by Dr. Roy Felding. Systems that follow Dr. Felding's principles described in his dissertation are called RESTful. So, what are those principles? The main architectural principle of RESTful systems is that everything is defined by the data. In REST, the data is called a resource. Every resource has a unique addressable location. This is represented by a web address. Just like getting a web page in your browser, getting a RESTful resource is as simple as, give me the resource at this URL. In this example, we're defining Green Lantern comics as our resource. We can ask for a single issue by adding an ID to the endpoint, in this case 148. This means the data for the Green Lantern comic number 148 is located at this endpoint. REST is HTTP. It's as simple as that. The REST commands are the same well-defined HTTP commands. GET returns a state representation of the resource requested. POST creates a resource. PUT updates a resource at an identified location. And delete, well, that's obvious. It deletes the resource. Resources are returned in the form the client requests. This just means you can ask for a resource in the format you want, and if the REST API supports it, you'll get the resource in that format. For example, if you ask for the resource as XML and the API can represent your resource as XML, the API will return your resource as XML. This is called content negotiation, and we'll cover it in depth soon. REST is stateless. You ask for a resource, and you get the resource in the state that it exists at the time that you request it. After that, the conversation with the server is over. This is something to keep in mind if your application needs to ensure it's working with the same resource that exists on the server. The last principle is a bit of a mouthful. Hypermedia is used as the engine of application state. Basically, this means the resource that is returned to you also includes what interactions with the server you can have next. If you ask for a page in a book, you should also include links to the next page and the previous page. A user should be able to make requests to a single API resource and be able to programmatically navigate your entire API. REST has several unique advantages over other web service technologies. It's very simple. Since it's based on HTTP, it's very familiar. Most programming languages already know how to make HTTP calls. Every resource in your system is represented by a web address, and that means users already know how to use your system. There are a limited number of verbs: get, post, put, and delete, and those convey the intention of the service. This makes REST calls very self-descriptive. REST is very lightweight compared to other solutions like SOAP or RMI. REST calls can easily be made from AJAX on a website or from a mobile application. Mobile devices have limited capabilities, so a lightweight solution can't be overstated. As you'll see in this course, REST APIs can be implemented and deployed quickly. The code is simple, which makes it easy to maintain. Development can be scaled too, since each resource endpoint can usually stand on its own. Since REST applications are really just web applications, all the benefits from web applications apply. You can cache the results from GET requests, you can place your REST server behind a load balancer for easy scaling, and you can even test your calls from a browser. There are several layers which comprise a REST application. These are the client layer, the presentation layer, the domain layer, the data layer, and the data store, where your resources are persisted. The client layer contains the applications which access your REST API. This would be your mobile application or your web pages. Since almost any language can make REST calls, the tools you use at this layer can differ from project to project or even within the project. The presentation layer is the layer made from your REST endpoints. These are the classes that respond to the client requests. We will use something called the Java API for RESTful services for this layer. The domain layer is a layer that knows how to build the resources for the presentation layer. This layer has your domain or business objects that represent your resources. The rules specific to your business live here. This is custom code that you write inside of Enterprise Java Beans. The data layer holds the classes that represent your data. The data objects are not necessarily the same as your resource objects. The domain objects usually are built from multiple data objects. We will use the Java Persistence API for this layer. The data store is where the data ultimately lives. This could be a relational database such as MySQL or Oracle, flat files, or whatever method you use to store your data. So now you know RESTful applications are web service applications which map to HTTP. Any application which adheres to the principles outlined by Dr. Roy Felding are considered RESTful. You've seen that RESTful applications have numerous benefits over other technologies, including simplicity, familiarity, size, maintainability, and scalability.
We've also covered the basics of the different layers we're using to architect our RESTful application. In the next video, we're going to cover the tools used in each layer.